Alright, today we're going to talk about Math 111, Section 2.4, Writing Equations of Line. The key word here is writing equations. Our answers to many of these questions in this section will be equations of lines, so we're going to be writing lots of equations today. Let me start out. I want to derive a particular line equation form for us. We're familiar with some forms, but I want to evolve or derive one in particular. Let's say we've got a line. Any line. Any non-vertical line. Let's say this non-vertical line will hit the y-axis at the point 0, b. So any non-vertical line is going to intersect the y-axis somewhere. I'll call it 0, b. Let's say, again, this in general, this is any line, and let's say this line has another point on the line. I'm going to call it x, y. Unspecified point on the line. Alright, at least in theory I can calculate the slope of this line by taking the difference in the y coordinates over the difference in the x coordinates. So I've got y minus b over x minus 0. That is the slope of this unspecified line. Alright, I can simplify this a little bit. X minus 0 is of course 0 in the denominator. And what I'm going to do is take this expression for m and solve it for y. What I'm going to do is multiply both sides by positive x. And if I then add b to both sides, I get the statement y equals mx plus b. Now because x and y were any unspecified points on this line, I can say this really represents the line equation in what we call slope-intercept form. Let me write this solving for y, reading from left to right. So in general on this line, y equals mx plus b for any x and y point on the line, and this is the line equation of this line in slope-intercept form. So I have derived very simply really the slope-intercept form of a line equation. Very powerful because you can see, you can by inspection really determine the slope and the y-intercept of the line if you're in the form y equals mx plus b. Alright, this is by far the most powerful and most used of the line equation forms. EQN is going to be my abbreviation for equation, if that's alright. Powerful and most used of the line equation forms. Alright. Let me give you an example of how you can use this. Let's see. Example. Right. Equation of line. Remember we talked about writing equations of lines? That's the title of this section. And here we are asked to write an equation of a line with slope equal to -1 and a y-intercept of 0, 7. Well, again, slope-intercept form tells me if I know the slope and I know the y-intercept, I can instantly write down the equation of this line really by inspection. So y equals minus 1x plus 7. Of course, we'd probably write this y equals minus x plus 7. Alright, so not much to that. Let's try another one here. Example. A little more involved. Again, write equation of line with a slope of positive 4 and through the point 5, 9. 5, comma 9. Alright, so we know the slope, but we don't know the y-intercept. This is not the y-intercept. If it was the y-intercept, the x-coordinate would be 0. Remember, to be on the y-axis, your x-coordinate must be 0, right? Alright, so, well, I'm halfway there. I know what the slope is. I can write down the slope, y equals 4x, but I don't know the y-intercept. Well, that's an easy enough fix. I can take the coordinates of this point then and substitute them into this line equation. Right? If a point is on the line, it must solve the line equation for that line. So then I can use those coordinates, plug them in, and solve for the unknown b value. Well, short work here. So 9 equals 20 plus b, and of course b is going to be then negative 11. So my final answer would then be y equals 4x minus 11. This line has a slope of 4 and a y-intercept of negative 11. Alright, up the ladder we go. Another example. Write equation of line with a slope of minus 2/3. A fractional slope, and through minus 4, comma 5. Alright, so again, I'll start out with slope-intercept form. I know the slope, but I don't know the y-intercept. I'll plug in minus 2/3 for the slope, and let's try to solve for the unknown b value. I will plug in the coordinates of the point I'm given. So 5 equals minus 2/3 times minus 4 plus b. Performing a little fractional arithmetic. 5 then equals 8/3 plus b. I'll subtract 8/3 from both sides. 5 minus 8/3 then equals b. 5, of course, is 15/3 minus 8/3 equals b, which of course is 7/3. So my slope is minus 2/3 and my y-intercept is 7/3. So my final answer, again, you're not done until you write a line equation, typically in slope-intercept form. There's my final answer. Y equals minus 2/3 x plus 7/3. This is a line with slope of negative 2/3 through the point minus 4, comma 5. Another example. Write equation of line through minus 2, 5 and 4, comma minus 3. Alright, how are we going to work this one out? Well, we're not given a slope, we're given 2 points in this line, but not to worry, we can always compute the slope of a line given any 2 points. That's a small matter as covered in section 2.3. So slope is then going to be y2 minus y1 over x2 minus x1. Be careful of the signs here. So I end up with a minus 8 over a positive 6, which of course reduces to minus 4/3. So my slope for this line is then minus 4/3. Hence, I know my line equation is going to look like this, but I still have to find the y-intercept. Again, I can plug in either of these coordinates that I'm given. There may be an advantage to one or another in some problems. I don't really see any advantage to one over the other here. I'm going to use the second point here. So when y is minus 3, x is going to be positive 4. Okay? And I can solve for the unknown y coordinate very easily now. So minus 3 equals minus 16 thirds plus b. And if I then add 16 thirds to both sides, isolating b, well, minus 3 is minus 9 thirds plus 16 thirds. That's going to be 7 thirds. So my y-intercept is positive 7 thirds. And now I'm ready to write down my final answer. So y equals minus 4 thirds x plus 7 thirds. There's my final answer for the equation of the line through those two given points. Alright, let me get a fresh screen here. Alright. Using slope as a graphing aid, we can actually use slope-intercept form and calculations therein as an aid to graphing lines. Remember, in section 2.2 we graphed lines basically by a trial and error process. We made a table of values, we picked an x, solved for y, we picked a y, solved for x, and it was kind of a time-consuming process, depending on the problem, I suppose. Let me give you an example of how we might use the slope-intercept form to speed our graphing process. Find slope and y-intercept and graph the following line. 2x plus 3y equals negative 9. Alright, this line is in standard form. You may recall from section 2.2, a standard form of a line equation is basically a multiple of x plus a multiple of y equals some constant, but a standard form really doesn't tell us much. Right? To determine the slope and the y-intercept from a line equation, you've got to convert it to slope-intercept form. So in order to find the slope and the y-intercept, perhaps the quickest way to do it is convert it to the form y equals mx plus b. Then I'll be able to spot the slope and the y-intercept. Alright, so I'll start out with 2x plus 3y equals 9 equals minus 9. Sorry. I want to solve for y. So I'll subtract 2x from both sides. And then divide both sides by 3. Both sides, all terms. The 3's cancel out on the left, of course. And I can now break up that numerator subtraction over a common denominator. And of course I can simplify this. Minus 9 over 3 is of course minus 3. So what I've got is the same equation that I started with, but in slope-intercept form. All right, let me write that down. This is the same equation that we were given in the beginning of the problem, but in slope-intercept form. By solving for y, we get it in slope-intercept form, and the beauty of this now is we can spot the slope. The slope is minus 2/3. The y-intercept is minus 3. And what I can do is use that information now to sketch the graph very quickly. Let me show you what I mean. I'm going to sketch the graph. Let's see. Can I get the y-intercept? Let me see. Let me draw it. There's the y-axis. There's the x-axis. My y-intercept is going to be negative 3. So what I'm going to do is start the line, or start graphing this line at the y-intercept of minus 3. So when x is 0, I know y is minus 3 on this line. I do know the slope is minus 2/3. And remember, the slope is always your ratio of rise to run. That means if I run 3 units, that indicates a 3-unit movement to the right, I correspondingly rise a negative 2 units. So what I'm going to do is draw what I call a little slope triangle here. A movement to the right of 3 units will result in a corresponding 2 units of drop in the y-coordinate, and I can indicate another point on the line. Right. If this point has the coordinates 0, minus 3, well, if x goes up by 3 and y goes down by 2, I can indicate another point on the line in this fashion. Right, so I'll connect those 2 dots. 2 points determine a line. So there is a nice, easy way to graph the equation of the line, really in any form. So the original form, probably best to label the line equation in the original form that you were given it, 2x plus 3y equals minus 9. So let me label it in this fashion, 2x plus 3y equals minus 9. You could also label it with the slope-intercept form, as long as you label it correctly. Okay? So slope-intercept form can be used nicely as an aid in graphing. Let's try another one. Let's ask you to graph 3x minus 2y equals minus 4. I'm going to do it in the same way. First, I'm going to convert to slope-intercept form. I'll subtract 3x from both sides. I'll then divide everything through by minus 2. I'll get y equals positive 3/2 x, and minus 4 over minus 2 is plus 2. So I know now the slope is 3/2 on this line, and the y-intercept is positive 2. I can use this information to sketch a quick graph now. If my y-intercept is 2, that means 0, 2 is on this line. I'll start there. If I run 2 units, I will rise correspondingly 3 units. So I'll indicate a 2-unit run, which will result in a 3-unit rise. To locate another point on the line, I can easily write the coordinates of this point. If x goes up by 2, y is going to go up by 3. So I can locate another point on this line at 2, 5 and connect these dots to indicate the graph of the line, and I'll label the line with the original equation I was given, 3x minus 2y equals minus 4. So again, graphing, some tough graphs can be easily graphed using this slope-intercept form with little algebraic transformation. Alright, I want to talk about one more subtopic here, parallel and perpendicular lines. Alright, well, we know from section 2.3 that parallel lines have equal slopes and perpendicular lines have negative reciprocal slopes. Alright, so let me cite to you a problem type. Let's say we've got a line. I'll call it line 1, L sub 1. Yeah, hang on a minute. And I'll say it has this equation, 2y equals minus 3x plus 12. And let's say I've got a line, I'll call it line 2, L sub 2, and I'll say this line has equation 6x plus 4y equals 7. And I'll ask you this question, are L1 and L2 parallel, perpendicular, or neither? Kind of a standard regions type question. And kind of hard to tell by looking at these line equations if they're parallel, perpendicular, or neither. Well, what I'll do, the easiest way to do this is to figure out what the slope is. And the easiest way to compute the slope is to convert it to slope-intercept form. So what I'll do is find the slopes of these lines, find the slopes, and compare. If the slopes are the same, they're parallel. If the slopes are negative reciprocals, they're perpendicular. And if they're neither, then they're neither. Alright, what I can do is take L1, convert to slope-intercept form. Alright, so I'll start out with line L1. Well, if I solve for y here, let me take 2y equals minus 3x plus 12. To convert it, all I need to do here is multiply everything through by 2. And I get y equals minus 3 halves x plus 6. Now, I don't care so much about the y-intercept for this type of problem. All I'm really interested in this line is the slope, and the slope is minus 3 halves. Now I'll take line 2 and convert that to slope-intercept form. I'll start out with 6x plus 4y equals 7. I'll subtract 6x from both sides. Divide both sides by positive 4. All terms, both sides. The 4's cancel out. I get y equals, well, minus 6/4 reduces to minus 3 halves. 7/4 I don't really care so much about here. Well, the slope of this second line is minus 3 halves also. Alright, so I think you see where we're going here. The slopes are equal, implying the lines are parallel. So with a little work in converting both lines to slope-intercept form, we can easily spot the slopes and make a quick comparison, and here it turned out they were parallel. The slopes were the same, so the lines are parallel. Let's try another one. Get a fresh screen. Let's give you line 1. 3x plus 2y equals 6, a line in standard form, and another line, line 2, also in standard form. And I'll ask, are these lines, are L1, L2, again, parallel, perpendicular, or neither? Alright, the easiest way is to compare the slopes, and the easiest way to find the slopes are to convert to slope-intercept form. So in essence, I solve for y in both line equations. So 2y equals minus 3x plus 6. I'll divide both sides by positive 2 here. I get y equals minus 3 halves x plus 3. So the slope of L1 is going to be minus 3/2. Alright, so I can say then M1, the slope of line 1, is minus 3/2. How about line 2 now? Again, I'll solve for y, subtract 2x from both sides. Divide all terms both sides by negative 3. And I get y equals positive 2/3 x minus 2. And the slope of this line is positive 2/3. So m sub 2 equals 2/3. And we can easily see now that these slope values are negative reciprocals. Negative and reciprocal of each other. And of course, if your lines have negative reciprocal slopes, then they are perpendicular. That'll be the final answer there. Alright, two more examples regarding parallel and perpendicular lines I want to talk about today. Example. Let's say I ask you this. Write equation of line through minus 2, 5 and parallel to y equals 8x minus 3. Alright, so we know our line, our needed line, has to go through a particular point, and we've got to be parallel to this line. Now, if I'm parallel to this line, well, that means I'll need a slope of positive 8, right? Because parallel lines have equal slopes. So what I can do is start writing my line equation. Well, the needed line has to look like this. It has to have the same slope as the line I'm supposed to be parallel to, right? So I can fill in a slope of 8 and determine my unknown y-intercept, and we'll do this in similar fashion as we've done before. I can then plug in the coordinates of a known point on the line when y is 5, x is minus 2. So then I can add 16 to both sides and get b equals positive 21. So my final answer then is the line y equals 8x plus 21. It has the same slope as the line I'm given with a y-intercept of 21. Let's do an example of a perpendicular line. Right, equation of line, again, through a given point. Oops, it's positive 1. Let me change that. Through positive 1, negative 5, through that point, and perpendicular to this line. Alright, well, the rub here, what's different here, we don't need a parallel line, we need a perpendicular line to this line, but this line is not given to us in any memorable form. Well, what we've got to do is find the slope of the line I'm given, then determine the slope of the line I need, remembering they have to be perpendicular. Again, the easiest way to determine the slope is by writing things in slope-intercept form. What I'll do here in this equation, I'll add 3y to both sides and then subtract 4x from both sides. Again, my goal here is to isolate y. And then divide both sides by positive 3. I'll get y equals minus 4/3 x plus 20 thirds, and I'm not so much interested in the y-intercept here as I am in the slope. Alright, so the slope of the line I was given is minus 4 thirds, right? So remember, the line we need is perpendicular. So we must have the negative reciprocal of minus 4 thirds. So I'm going to need a slope. Well, what's the negative reciprocal of minus 3/4? Of course, that's, what's the negative reciprocal of minus 4 thirds? That's, of course, positive 3/4. So, hang on a minute. We were given a slope, a line with a slope of minus 4 thirds, so we need a new slope of positive 3/4, right? Alright, so I know my equation must then look like this. Y equals 3/4 x plus b, but we don't know the y-intercept. How am I going to find the y-intercept? Well, as before, I'll go up and see the point I was given was 1 comma minus 5. See it there? 1 comma minus 5. And I can plug in those coordinates. When y is minus 5, x is going to be a positive 1. And I can use that information then to solve for b. So minus 5 equals, well, 3/4 times 1 is just 3/4. I'll subtract 3/4 from both sides. Minus 5 minus 3/4 is b. Well, negative 5 is really negative 20/4. Multiplying top and bottom by 4. Minus 3/4. And if I subtract those fractions correctly, I get a minus 23/4. So my final answer then is I need a slope of positive 3/4 with a y-intercept of minus 23/4. That is the equation of the line through minus, let me start again. That is the equation of the line through positive 1 minus 5 with a slope of 3/4. And that was a minus 23 in the numerator there. I just made it a little clearer. Alright, so that concludes this lecture. We're hitting the 33-minute point. So that's all for section 2.4, writing equations of lines.